this is Emmett, and today I'm presenting Lab 3 on a star orbiting a black hole. The goal of this lab is we are trying to determine the mass of the black hole that the star is orbiting. We assume that the only force acting on the star is the gravitational force of the black hole, and we use the equation, the constant g times the mass of the star times the mass of the black hole divided by the radius squared. The given information is a list of locations of the star in a CSV file, and we also know the mass of the star, and we know the location of the black hole. The other equation we'll use in this lab is the change in momentum over the change in time is equal to its components added together, and also that the change in momentum over change in time should equal the net force. Next, using the given information and the skeleton code provided, we make a model to represent the star's movement around the black hole. Here I put in the given information, the mass of the star, and the time step, which is 86,400 seconds, or the amount of seconds in a day. And then we edit the initial momentum, which is the mass of the star times the initial velocity, and the final momentum, which is the same mass of the star times the final velocity. And then in those we find the differences between the two. So here's my equation for change in momentum over change in time, which is just the change in momentum over the change in time found here. And then we set that equal to the net force. Next, we find the parallel component of the change in momentum over change in time. And you can see here we just simply subtract the initial momentum from the final momentum, and we divide that by the change in time, and then we get that on one plane using this. And then we set that the change in momentum over change in time to the FNet parallel. And then the perpendicular we simply find by using the total change in momentum over change in time and subtracting the parallel component. Continuing on through my code, we find the radius between the star and the black hole using data points from the CSV file and the location of the black hole given to us. And then we find the mass of the black hole by rearranging the equation that the force of gravity equals the constant g seen here times the mass of the star times the mass of the black hole divided by the radius between them squared. And we rearrange that, as you can see here, to bring the mass of the black hole to the other side and having it equal to the magnitude of the net force times the radius squared divided by the gravitational constant times the mass of the star. And then, in order to find a more accurate mass of the black hole, we find the averages of all the masses of the black hole found in this loop. And the way we do that is we add together each individual black hole total we find, and then dividing it by the number of data points we have. Alright, here you'll see my model being run. Yep. You'll see three different arrows, and the black one is the net parallel force, or the net force parallel. The blue arrows, the net force perpendicular, and the yellow is the total net force. And you'll see that it prints out here the mass of the black hole, or the averages of all the mass of the black holes added together. So the questions for today are, what is the difference between change in momentum over change in time and net force? Well, change in momentum over change in time looks at the motion of the star, while the net force simply looks at the forces upon the star. Even though their magnitude will equal each other, they are actually focused on different things. Second question is, imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? Well, no, because the mass of the black hole would be the same if the motion of the observed star remains unchanged. Therefore, all the data would be the same, and the mass would be the same also. So we conclude that the mass of the black hole is 2.62 e to the 31 kilograms. Thanks for listening along with me today, guys, and I hope you all learned a lot.